Well, good afternoon, everybody. Thank you for your time today. So, great, we're going to talk about Flash this afternoon, SSDs, and I'm pretty excited to talk about what we'll need to do to make that a reality. I have a particular view, and I'm looking forward to a discussion about what you think we ought to do. So, you can read this when we post it later. We'll get through that, the premise here, but. So I wanted to talk about doing, talk about the technology disruption that Flash brings and into parallel file systems. And people are now considering using Flash for their primary storage, their primary parallel file system storage. And the message that I think that we'll come to we'll see today is that yes, that's possible. It's certainly possible to consider. It didn't always make sense though, right? We had, we've heard, again, there were questions from this morning with Lustre and the software stack being as it is, it doesn't make sense to do lots of small I/O. So, if you needed to do lots of small I/O, you do that somewhere else. Well, Flash, if you insert Flash into a Lustre and, the characteristics of Flash being random access, low latency, you'd think it would be ideal for small file I/O. And with the Lustre software in the past, that didn't make sense. We've been looking at that. There's been a little bit of work there. In fact, Patrick Farrell will be talking later this afternoon, spent some time looking into that. And I think we have good news to report about small file I/O on Flash. Also, the hardware didn't make sense either. So from a architectural standpoint, if you had a bunch of spinning disks behind an OSS and a network, a network pipe into that thing, if those spinning disks could give you all the bandwidth you needed to saturate that pipe, it didn't really matter if those were spinning disks or stone tablets or whatever. If you had enough bandwidth on the back end, it was fine. Now with the advent of features like multi-rail LNet, we can see much larger pipes coming into object storage servers, and so then it becomes more important to make sure that the backend can keep up with that. So in the near-term future, we'll see, 200 gigabit, multiple 200 gigabit links coming into an object storage server, and with Flash, we can take advantage of that. So message is, I think it's time to reevaluate looking at Flash and where it fits into the storage architecture, particularly with Lustre as a parallel file system. So, life is good, right? We add Flash and our users are happy, everybody's happy, right? In fact, I just wanted to throw a couple graphs on the screen. I don't expect you to be able to read the axes or anything. Just to make a point here that we've been looking at the performance of Lustre on Flash, and it in particular, it's doing better than we thought it could do, right? In terms of, again, small I/O, we've tried to analyze rather the client-side stack in particular, and see where the time is going, and we've been able to make some optimizations building on work of others. And again, Patrick will be talking about that shortly. So if we take a view that Flash is great and solves a lot of our problems, then life's good, right? Well, is it? Because the economics of Flash are such that, and the technology is a little bit limited, right? In comparison to disk, the capacity is much, much smaller, right? And so the reality is that we're going to need to deal with both of these things. We're going to need to deal with Flash, we're going to need to deal with disk, and we're going to need to figure out how that fits into the storage architecture. We're going to need a capacity tier, essentially, that's disk, certainly, and the question is, how will Flash augment that disk? And for those of you that had the privilege of attending the Oak Ridge National Labs, US National Lab, Lustre Ecosystem Conference this year, John Bent gave the keynote on the second day. I'd actually like to welcome John onto the Cray team too. He just recently joined us a few weeks ago. But he gave a great talk, and I'd encourage you to go check out the slides, which are available online. And he talked about, sort of the same things, right? Some of these architectural issues. How do we view the system architecture? How does Flash fit into that? This is something that he's been looking into a long time. One of the funny quotes from, takeaways from his talk was this thing that he called Lang's Law from his buddy Mike Lang at, I believe, Sandia or Los Alamos. I'm getting them mixed up right now. But he was asking his colleague, like, how do you want the storage to be tiered, right? Do you want so much burst buffer, so much parallel file system, so much archive, so much, etc.? And Lang said, look, we don't want all these tiers. We just want an ideal computer. The tiers are, a side effect of economics, right? So, and they're a pain in the butt to deal with. So the more tiers, the more tiers. And so Ben took a look at this, and he came to the conclusion that, yes, while we may have a lot of physical tiers, that we really want to keep things, from a human perspective, as simple as possible to manage. And that really kind of meant that we were going to live in a world with 2 tiers. So I'd encourage you to check out that talk. It was really good. And I agree with a lot of what he has to say. It's too hard to manage these tiers, and we don't have all the tools to be able to do that. And so I agree, we want a storage architecture that includes both disk and flash. And so how do we do that? So just for a moment, consider what is an evolving today memory storage hierarchy. You've got a whole bunch of very low latency, high bandwidth devices, sort of at the top. Whoops, wrong button. Well, so on the right-hand side, you can see here, just quickly, we've got CPU caches at the top, we've got, tape at the bottom, all kinds of stuff in between. And we've got to think about the data movement between these layers, right? And just keep in mind a few things like, new technology like storage class memory devices, those, while they may be persistent, they can only really serve as cache. They're really intended to be used in a temporal sense, right? And, also thinking about flash, right? Where could it be? How could it be used? It could be private, node local, for example. It could be shared on a network, or it can be embedded in the storage device, or in the parallel file system. And we want this to be simple, right? We want to be able to actually use it and not have to suffer and cry about it. So let's think about putting flash into the Lustre file system. So this is one of the things that, if you look at Ben's talk, he didn't actually consider that. He talked about the node local case. He talked about flash on the network in a shared case. He talked about it being embedded in the object storage servers transparently, but he didn't consider flash being a Lustre tier in the first sense of it's visible in the Lustre file system. So I think having talked about the performance briefly, and again we'll get a chance to look at that again later today. I think that the performance case is there. We'll see that the performance is enough. But I also think that just putting flash into an OSS and making it available in the file system isn't enough, right? We need to do more than that. And in terms of functional software and a functioning system that operators and users can use alike. And we have existing Lustre tools that can help us leverage this, right? So we've got things like OST pools, that those things were designed to naturally segregate storage classes. And now we've got complex layouts and progressive file layouts. Things like PFL are great. They're a boon to tiers. They allow us to do things like set a stripe for a file or a directory that could fill a tier of flash storage, and then when that's in danger of becoming full and you're still growing your file size, you can break out into the rest of the storage targets out there. So that's great. And we've got things like file replication that are coming soon. But again, that's not quite enough. I think we need to do quite a bit more to make tiers of first-class citizens, so to speak, within the Lustre file system, really make them truly usable by the people that are using that parallel file system. And I think there's really three things that we need to think about here. We need to think about data placement, we need to think about data movement, and we need to think about how we manage that. So in terms of data placement, we need to be able to explicitly declare how we want to place our data. For example, LFS set stripe sort of things. But we also need to have tools that make it implicit, right? So, for example, if I set in the future a layout for my file that indicates that I want to have a replica, maybe the system will know that I need to place that replica in a certain place, and then maybe move the data at a certain time accordingly, right? All these kinds of things I think we need, and again, it breaks down into these three categories: data placement, data movement, data management. But there are some Lustre-specific issues that I think we need to take a closer look at that are going to make this difficult. So when we're dealing with flash technology, again, we're going to be a little bit limited in the capacity of these devices, and there's going to be a lot of demand. There's a lot of inherent performance there, and our users are going to want to take advantage of that, right? So we've got relatively small capacity and lots of demand. There's going to be, there will be problems, right? We're going to fill those things up, and they're going to fill up instantly. And the problem is that we don't have any tools in our, we don't have any Lustre tools to help us manage that. There's no way to restrict, the amount of stripes that land on in a pool, for example. OST pools are just ephemeral. You can define them to be any collection of OSTs that you want. You can also stripe your files across all the OSTs. So suddenly you have a user that just unfortunately picked your OST pool full of flash devices and filled it up with a big multiple checkpoint restarts and left them there. Well, now he's kind of ruined the experience for everybody else. And subdirectory mounts aren't something that can help you here, because again, you can just still stripe over these things. So we need to address that. And as I talked about before, progressive file layouts are going to be great. We're going to be able to kind of buy us a little bit of insurance, so to speak, when we want to stripe some files and use the flash tiers, right? But we know that if the files were to continue to grow, they would exhaust the space there, and then so PFL allows us to sort of break out again. But these tiers are going to fill. PFL isn't enough all by itself, and when users' jobs fail, they're going to call it operators. Operators are going to have to stop jobs. They're going to have to clean up the mess. And by the way, they don't have a lot of good tools to be able to do that either. And so now next step here is, okay, we've filled up a tier of flash storage, right? How are we going to deal with that, right? How are we going to drain the tier? We really have to think about how we're going to orchestrate the data movement and marshal data among these tiers, right? So there are a lot of questions about how we could do that. So some things to think about would be, does the user do it? If the user does it, how do they do it? Do they get the job scheduler involved? Does the job scheduler do some stage in, stage out for them, and then that's the only that's the only tool that you have available to you? Or is there, maybe the user has an API that they can explicitly use, or maybe the system knows. Maybe there's some policy engine that we'll add into Lustre that says that monitors the fullness of an OST or perhaps a pool and says, oh, I've reached a threshold. I need to step in and do something to save this file system from filling up this pool. Maybe some combination of both. And then another thing to think about when dealing with these tiers of storage is how they're used. Is this going to be a burst buffer? If so, you may want to treat it differently than if it's just, a general purpose OST. If it's a burst buffer, perhaps you don't need to figure out a way, you don't need to drain the whole thing. Maybe you just have some temporary files that are a temporary checkpoint restart. Maybe you've got 10 checkpoint restarts and you've persisted 3 of them. you're probably fine, right? But yet Lustre has no awareness of the data that's there, what its purpose is. It has no way to know what needs to be persisted and what doesn't need to be persisted. So again, I think we need to invent some way to think about that. And if we do, we need to be able to empower people to make these decisions, or empower software to make that decision. And then there's just a few logistical questions that we need to also deal with. So we want, getting down into the mechanics of things. If we've got a bunch of small files there, we've got a little bit of a dilemma. We use the flash, we use the inherent capability of that flash to suck up lots of small file I/O, right? And it was great at doing that, but now we need to drain that to perhaps a disk tier, which isn't so great at that. And if we've got a lot of small files, we've just defeated the purpose of kind of using that flash tier in the first place. So we want to think about how we're going to drain that. So perhaps if we've got a lot of small files, we can tar them up and move one blob out of the way. If we're using file level replication and we decide to go make a bunch of replicas, that's going to cause some metadata load to even update the layouts, right? And so, if we are persisting the data in the flash tier to a disk tier, one of the things that we can remember is we can still put flash embedded in the OSS, right? We can augment that capability as well, and we can do that in a transparent way. Another logistical question, and this one is really, I think, the key to making this work. Can we start the process before the job is done, right? So we're writing into these tiers of flash. We don't know how much we're going to write in there, or perhaps we do. Maybe that's another bit of information that we can get along the way. But in the meantime, we might be in danger of filling this pool up. We need to be able to decide when is the time right to start moving that data, and ideally it would probably be while the job is still running. In fact, ideally it would be while I/O is still occurring to that file. So can we do it before the close? And I'll talk about that a little bit later. I think we can. And I said ideally because I think that in an ideal sense, we'd want to present these pools as a data sink that never fills up, right? So I can write whatever I want into it, and Lustre will do the right thing to drain the tier, on the rest of the tiers, say the capacity tier. And because that'll allow me to always use that flash for its intended purpose, right? The highest performance, highest capability storage that my Lustre file system has to offer. And if we do that, then we can always maintain that high level of performance. Like we won't always have to say, oh, user, I'm sorry, this flash tier is full. Today you're going to have to use the disk tier. And your job will take X times longer, right? So getting back into data placement, our users are very accustomed to, they're either oblivious to file striping, right? Or they're totally at home with it now and are used to doing things like controlling the striping. But we need to give some messaging about how we expect them to deal with striping with tiers of flash. The OST kind of granularity is the wrong way to think about it. And yes, we have OST pools, and you can use LFS set stripe today with a pool. So clearly pools are a better way to think about this. But as I said before, we don't have any access controls for those tiers or that pool of storage today. And so it's sort of a free-for-all. Anybody can put their data there. And we don't have quotas available. There are project quotas, but still that doesn't prevent somebody from putting their data onto that pool. So I think we need to think about whether they're treated as free for all, and I think we need to start treating them as a scarce resource that they will be. And so if we're going to express data placement, explicitly, via set stripe or some other way, hey, do I want to say, oh, or maybe perhaps put a quota, which I think we'll need to do. Do I want to say I want to use 50% of this tier, or do I want to say I want to use, is it a relative size or is it an absolute size? Like, oh, I just know I'm going to need 100 terabytes or whatever it is of storage. So let's think about that when we're contemplating data placement. And so getting back up to a higher level, it's clear to me that Lustre needs some answers here to be able to make Flash work. Again, the issues boil down to placement, movement, and management. And so it seems somewhat clear to me, and we can have a conversation about this, but I think we need pool quotas for the reasons we talked about before. We need to have file level replication to make it easier to, as a draining technology and as a persistence technology. We need to be able to move that data automatically. We can't, it just absolutely has to happen transparently in many cases, and it can happen explicitly, but we have to be able to set policies, for instance. We have to be able to control that programmatically. And again, we want to express these things both implicitly and explicitly. And it's got to be easy to manage. Now, my thinking here is that this is mostly external to Lustre, right? Because Lustre doesn't have a policy engine built into it today. And of course, there's been some talks about that over the last year or so. But I think, for one, that policy engine has a large role to play in how we manage this data movement. And so we're going to need to think about that. We're going to need to think about providing hints into Lustre, perhaps via LAdvise, and getting job schedulers involved. And if we do these things, that's how we get from the concept that we have of OST pools today to thinking about that pool as a tier, like a first-class construct within Lustre. So what do we need to do to make that happen? So I've kind of thrown together a ranked list of things that I think we need to do, and it starts with finishing off file level replication. I think that'll make that'll do a good. That's a base that we need to build on, right? It'll be a great help to us. And then as we're thinking about that data movement, how do we orchestrate that? We need to think about being able to initiate that data movement from a policy engine, from a job scheduler, and maybe perhaps with a script. We need to put those things in place. We absolutely have to expand the functionality around OST pools that we have today. So we need some administrative tools to set quotas for pools, and we can extend project quotas to fit the bill there, and then we'll have things like PFL to buy some insurance, so we can break out of the tier once we've hit our quota. We don't necessarily have to stop writing everywhere. So we need some sort of, pool tier soft quota there. And in fact, we would maybe, this is back into data placement, but we would think about setting that PFL in an implicit way, right? Like if I just set my stripe to the pool, it could know, what's your quota? I'll just set your PFL. I'll set your layout for this object such that when you hit your quota, you'll break out into the rest of the OSTs. So I think that'll be a very powerful thing for us to have. And then getting back to file level replication, we absolutely need to be able to do this while the file is open for write. And so as a poor man's implementation of this, implementing this to start with, I think a good place to start would be, and I talked to Nathan about this yesterday. This is a great idea from Nathan Ruttman. You start a copy, and you don't get an exclusive. You wouldn't take, for example, an exclusive group block on the whole object, right? You would take a read lock that would perhaps revoke some write locks for the range that you needed, but you wouldn't. But if another writer came along, you would just throw up your hands and say, well, I'll get to this later. I can persist this object later. So you could just start a copy, and if you needed to abort, you could. Later, what I think we would need to do is consider using some sort of enhanced group locking capability to put like a byte or an extent range. Say I'm going to archive this file or this object, but I'm only going to archive the first, I'm going to exclusively lock the first so many bytes or the first extent or whatever it is. And so I can do that without interruption. Also, I haven't really delved into how we would do those copies, but we would probably do those copies from a Lustre client, right? And if that Lustre client was on the server, it would need to get access to that data, and we'd want to be able to efficiently get that out. So what we'd want to do is bypass the network stack and do efficient server-side copies. And by the way, that only makes sense probably if we have a single straight file, because we wouldn't want to have ingest bytes into the flash tier and eject bytes out to the capacity tier, and then yet go as a Lustre client and try to read another flash OST so that we could persist the file. And so again, we want to treat small files with tiers as a group, so we might want to think about tearing those up. We might want to think about, as Karsten talked about earlier today, having a loopback file system. And then last but not least, I think we need to consider the client-side compression, because instantly, we talked about how limited these tiers are. We'll have, we'll be able to essentially maybe more or less double, depending upon the compression that we could get, the reach, and then and also the performance of these things, right? So if you put all that together, we'll talk about performance on Flash a little bit more later today. With small file I/O, single client improvements, streaming data, we're widening the Lustre sweet spot, so the performance is going to be there. We have the data placement, data management, data movement that makes it easy to use and easy to manage. I think we'll end up with high productivity systems. Thank you. Are there any questions, or is there time for questions? Thank you.
One question?
It's not so much a question as an observation. My users are scientists. They don't want to think about striping. They don't want to think about progressive fileouts. They don't really want to think about HSM. So anything you can do to make it automatic and transparent, that'll be perfect.
Yes, I'd agree. I think that's why we need to have, we need to think about that and put sort of some tools in place to make that implicit, right? The user's going to write files in a Lustre. They'll just use the Flash. The system can handle, the policy engine can move the data, whatever it is, make it work. Yeah, because if we don't do that, we'll have what I would call a poor man's or DIY solution, right? You have to manually manage that, move the data. It's just not tenable.
Yeah, I just wanted to add to that, like for ourselves, we definitely want things to be transparent, but like you picked up on in your slide about quotas and management, like that's essential for us. Like we definitely want to have like tiers of users, who some will have access to the Flash or other tiers, and some who won't, and not just a free-for-all. So like you say, because a lot of the burst buffer stuff I think at the moment is very transparent, like cache-like. That's useful, but we only want certain people to be able to benefit from that without having to like split the whole file system.
It's very good presentation. I have some comment and questions. So we implemented a K-computer. At the time, we implemented the staging and stage out such kind of very a combination of the job schedule. At that time, so there are staging capacity and computing capacity and stage out capacity. So that's kind of a 3 times amount of capacity needed. So, however, maybe SSD, the flash memory is not small, you said. So it's very difficult to combination of the job schedule. So how it completely depends on the system operation. So what most preferable thing to think about?
What do I think about
The solution.
overlapping
Yes,
stage in,
yes.
queue, stage out? Yes.
Yes.
So I think that we're going to need some monitoring solutions in place. And in fact, I kind of hinted at having hints, right? So one of the things that the application can do is give a hint to the file system saying, you know, maybe perhaps through the already existing L-Advise tool, hey, I'm done with my I/O for a while, I'm going to go compute. Well, the storage system can use that hint and say, oh, well, now would be a great time to go replicate the objects that you just wrote, right? And so that we don't conflict, you know, the use of the tier for compute and the use of the tier for persistence. So absolutely.
Okay, thank you, Cory.
Thank you.
Thank you.